All right, so this video is going to show you how to calculate flow rates if you're given a volume of fluid and a time. So a couple rules to keep in mind. IV pumps don't allow, most of them won't allow decimal points. And this is just for large volume fluids and pumps that you would use for that. So typically you're just going to be solving or rounding up to a whole number. We can give less than a milliliter, but we're going to use syringe pumps to do that, just by nature of the machinery and the computers and so forth. There will be some more technical pumps that might be able to do this, but in general, you'll round to whole numbers. Next, if you're given your time with hours and then you're given also minutes, the easiest way that I've found to figure these out is to convert your hours into minutes. So if you're given 2 hours and 10 minutes, you would convert that into 130 minutes, which is the same as 2 hours and 10 minutes. But we'll go through some questions here as practice. All right, so we're solving for flow rate, and none of these have drop factors listed, so we are going to be going for milliliters per hour. And these are very basic dimensional analysis. Try not to do mental math with these. Little errors can happen. So in this case, we have milliliters per hour already, so we're just going to do 600 divided by 7, and this is going to give us 85.7 milliliters per hour, which we would then round to 86. All right, next one, milliliters per hour again. So we're not given milliliters in the problem, but we have to start with milliliters with dimensional analysis. So I know that I can convert liters to milliliters, so I'll work towards that. 1,000 milliliters. It's the same as 1 liter. And then I'm going to insert my volume given. That'll allow me to cancel out my liters. And this will be over 6 hours. So I'm going to multiply 0.42 times 1,000 and then divide that by 6, which will give me 70 milliliters per hour. Oopsies, that doesn't look very pretty. Okay. All right, now we have one that gives us minutes. So this is where I was talking about, is converting it all to minutes. And this is allowing you to do dimensional analysis a little bit easier too. So this is essentially 2 hours is 120 minutes. And we're going to add the 35 to that. So in this case, it's going to be 155. And then we're going to solve for milliliters per hour. So we have 420 milliliters. And we have 155 minutes. And I need to get rid of my minutes. So I know there's 60 minutes in 1 hour. And now I'm going to multiply across. So 420 times 60 divided by 155 is going to be 162.58. So in this case, I would round up to 163 mils per hour. All right, last one here. We're again solving for mils per hour. I have 375 milliliters over 90 minutes. I'm going to need to cancel out my minutes and get hours on the bottom. So 60 minutes are in 1 hour. And that will give us 375 times 60 will be 22,500 divided by 90 on the bottom. That is going to be 250 milliliters per hour.